History rewards the innovator, the pioneer, the trailblazer. For over 30 years, Supermicro has been fueling innovators and visionaries with the industry's best computing resources. We have built the industry's widest portfolio of storage servers with the largest open ecosystem of leading storage hardware so that you can be first. Welcome to Supermicro's 2025 Open Storage Summit.
Hello and welcome to the Supermicro Open Storage Summit and this episode where we are exploring storage aspects of data lakes and lakehouses for enterprise AI. Today's rapidly evolving AI landscape, data lakes and lakehouses have become fundamental pillars of enterprises aiming to harness the full potential of artificial intelligence. These modern data architectures enable organizations to efficiently collect, store, and manage vast volumes of diverse data, structured, semi-structured, and unstructured across multiple environments. By providing a unified platform that supports both analytics and AI workloads, data lakes and lakehouses are revolutionizing how enterprises approach AI at scale. A critical enabler of successful enterprise AI is robust data ingestion and ETL or ELT, extraction, transform, and load, or extract, load, and transform processes. These ensure that high-quality, relevant, enterprise-specific data flows seamlessly into the AI models, enabling precise fine-tuning tailored to unique business needs. Without this fundamental step, AI initiatives risk being ineffective or misaligned with organizational goals. Enterprises leverage object storage for scalability and cost-effectiveness. This hybrid approach supports the complex demands of AI training and inference while maintaining flexibility across cloud and on-premise infrastructures. In this video session featuring industry experts, we will explore key considerations for designing effective data lakes and lakehouses tailored for enterprise AI success. From architectural best practices to technology recommendations, participants will share their insights on overcoming challenges around data integration, storage optimization, governance, and model fine-tuning. With that, I'm so excited to bring in our industry experts, starting with Brenna Book, who from MinIO, Simon Lightstone from EDB, Shiva Gurumurthy from AMD, and Paul McLeod from Supermicro. Hey, welcome on board, everybody.
Thanks. Thank you.
Welcome, Rob.
Thank you.
So to me, again, I'm a data geek, so this is one of my favorite sessions. Not that they're all, I'm not picking, a special baby out of all of the sessions here, but, really, I think this is one of those keys and something that, people, it's gotten a lot of press, but digging in and understanding what it means to be a data lake and a lake house and how that helps enterprise AI from the storage considerations is really important. So, Brenna, I would love you to kind of give us your view and MinIO's view of what's going on in this space.
Great, I'd be happy to. So there are three main components of a data lake house. First layer is object storage. This is the data lake part of your data lake house. It has to be performant, it has to be secure. If your queries are slow, if your data is insecure, your data lake house is not going to last very long. And you need to make good choices from the start in this layer because once you put your data in, it becomes really hard to move out. It's not very flexible. So you want to make sure that in this context, in the data lake house context, you choose a storage layer without a POSIX interface or a metadata database because these features will inject latency into your stack before you even get started. And of course, it has to be scalable. And by that, I mean, it needs to be as easily deployable on a laptop as it is in a data center. It needs to just work from a gigabyte to a petabyte to an exabyte and beyond. The next layer in a data lakehouse stack is an open table format. And this is where Apache Iceberg, Apache Hudi, and Delta Lake live. So this is the layer which gives you those database-like features to your data lake, things like ACID guarantees, time travel, schema evolution, partition evolution. It's really what gives the lake house its je ne sais quoi. So then you have the compute layer. So In past data architectures, storage and compute were really tightly coupled, meaning in order to scale one, you had to necessarily scale the other. But in this design, the storage and the compute are separate. That's why there are different layers in this design, in this slide. But that also means that this old concept of selling storage and compute together has sort of dissipated in light of this new stack, and now more and more users are able to just choose whichever compute works best for their workloads. And we often see our users adopt more than one. So you can use Snowflake and Dremio, or Dremio and Trino, or Trino and EBD. So one of the really amazing things that we've seen as an industry trend in the last few years is object storage as primary storage for both LLMs and for analytics use cases. So the major players in LLMs, large language models, OpenAI, Anthropic, Google DeepMind, they all have built their services on top of object storage. And similarly, the entire Lakehouse stack can operate over object storage. Dremio, Trino, EBD, they all can sip off data in object storage as if it was a native table without migration, which means that you have a faster time to insight, but also that you have an entire stack that just works together out of the box. And so you might be asking yourself, why should you believe MinIO? They come here to talk to you about data lakes. Well, we've built a lot of them. Out of more than half of the Fortune 500 companies, more than 1/3 of the Fortune 100 have all chosen MinIO to be their object storage. We have partnered with 8 out of 10 of the largest automotive companies, all of the top 10 US banks, and 8 out of the 10 of the largest US retailers. And it's not just enterprise adoption, we also have a tremendous developer backing with over 2 billion Docker pulls worldwide, over 51,000 GitHub stars, and a really vibrant open source community. So, whether you measure success on enterprise adoption or developer velocity, we're most everyone's choice for on-prem object storage. And my colleague Keith, in another session, will go into more detail about how the data lake fits into an overall AI stack, but this gives you a preview into that world. On the left-hand side, you have your data sources. So this is your ERP, your CRM data, your edge use cases, IoT, of course, your cloud resources, and it all flows into your data lake. So this is built on standard hardware, sold, produced, and created by our friends AMD and Supermicro. And then on the right-hand side, you have the consumer applications. So this is things like your visualization software, your LLM model, your vector database. All of these are the tools that end users use to create value out of your data. And wherever your data starts with and wherever you need it to go, this stack will take you there.
That's great, and I think that ties really well into our next speaker with Simon with EDB, because again, right at the heart of what is going on with Postgres and what's going on in this data lake house, data lake industry.
Right, yeah, and just as you say, there's a lot of customers who want to just use Postgres with their MinIO storage, using a data lake and using Postgres to query that, rather than learning some sort of other technology. And that's one thing I want to talk about here, as well as, from the EDB perspective, we're providing the hardware in a partnership with Supermicro to provide a solution, which we call the Sovereign Data and AI Factory, that just makes it very easy to use all the vendors that are speaking here, MinIO and so forth, and AMD, and of course Supermicro, to leverage that storage investment, right? To give that software layer, which allows you to automatically move to different tiers of storage as data gets old, to use it using open standards. A little bit about EDB. You've probably heard of Postgres, the database. So EDB is the #1 contributor to Postgres. And Postgres is now the most popular database. And also, it's the most loved database if you look at Stack Overflow rankings. But it wasn't always that way. We've been working on it for 20 years as a top contributor, the #1 contributor right now to Postgres, really believing that the database layer should be open. So now, of course, we've evolved. Now we also provide a lot more in terms of AI capabilities and so forth. And I'm going to talk a little bit about our data lakehouse capabilities here. And one way that we work with all the great Supermicro vendors, in particular MinIO as well for the object storage layer, is that we let you see everything, all your databases from one estate. So now you may have a lot of different storage there, and as you can see on the screen, you can now manage it all of your Postgres estate from one visual screen. And this just makes it easy to see what you've got left in terms of your compute, which was referred to by Brenna, and as well as your storage and what you've got left, and also to dive deep and diagnose any performance issues. Going from there, so that's sort of the interface that you're going to have to the storage layer as well as your compute layer, and it just makes it easy to see what's going on, to also add dynamically as you need. And when we partnered with Supermicro, we thought very deeply, we spoke to customers about what's important for them to provide a hardware solution, an engineered system, which we call a sovereign data and AI platform, that makes it easy for them to bring Postgres into their data center. So there are a few things that we want to focus on. One is mission critical performance, and that also means providing the flexibility to choose the storage that you'd like for the engineered system. So some customers may already have storage installed. They may have purchased MinIO a long time ago and they want to make use of that storage investment, or they may want to include and bundle the object storage with their purchase. But we allow them to really take advantage of what they have today, as well as, of course, having a very curated configuration to make sure you get the most out of your hardware, often getting a 6 times return on investment compared to regular Postgres. Also extreme high availability. So the system is modular. It consists of 7 or more servers, and you can place those across your data center in different availability zones or different fault domains or failure domains, depending on how you want to refer to it in your own data center. And that is going to let you have high availability, 99.99% uptime. If any of your fault domains or failure domains goes down, then your operations continue. And we make that easy, right? We set that up for you together with Supermicro. And then just turnkey simplicity in terms of automatically moving data to your data lake if you have a busy operational database, and allowing you to use whatever object storage you have. The simplicity of setup, really, it's a turnkey solution. Once you decide to give it a try, we go to your data center, and together with Supermicro, we partner and we set it up so it's highly available. And the next step is really deploying your next lakehouse cluster or Postgres cluster in just a few clicks. And finally, tying that together with AI, which we've all spoken about here, we make it really easy to leverage all the data in your lakehouse, in your object storage, or in traditional Postgres databases, even if it's open source community Postgres, and rapidly do RAG. Build RAG applications or RAG chatbots. What RAG does is it basically takes all your data in those lakehouses, in your object storage, or in standard block storage, and it lets the AI models query all that data and give much more contextual responses. So without further ado, I want to spend a little bit of time talking about lakehouses and how EDB really helps in that area. Again, we use open formats like Apache Iceberg, and it just makes it very, very easy to take some of the great hardware that we speak about here and then operationalize that really effectively.
Simon, that was great, and I think that makes a lot of sense about what you were saying and how it builds off of the hardware in that compute layer that you also then tie into the storage layer like the MinIO layer. Now let's get a little bit deeper into the compute layer with Shiva. Come on, help us understand where AMD is playing in this.
Right, so AMD sees data at the center of all things AI today, and at the center of data is actually storage, is the critical enabler of all the data that's out there, right? When we think of AI, we think a lot about compute, but it's really the disks and the infrastructure behind it that's running a lot of data today. So as I listed in the slide here, there are a lot of steps that involve a lot of the storage infrastructure of any particular AI deployment, data ingestion, a lot of data reads happening, pre-processing for AI data. That is a lot of read and write for all the data that is happening to prepare the data to be ready for AI. Training, obviously, GPUs do a lot of training these days, but to keep it fed with a lot of data, it's actually the storage devices that are doing it on a daily basis. And then checkpointing, these are the intermediate results storing, read and write into the storage while the training is happening. Inferencing is the next big thing with a lot of inferencing applications out there. They are going to be using a lot of these disk storage and storage systems, which require a lot of read and write again. And lastly, archiving. The models developed have to be stored, and a lot of access happens all the way through that. So that is also another step in the overall AI development that requires a lot of data storage innovations. And how does AMD fit into all this, right? So AMD, being a CPU and also a GPU company, has got a complete portfolio of products that actually enable this ecosystem. To be very specific about CPU, we actually have leadership per core performance, and also this is with 12 channels of memory channels per socket, and also leadership in terms of the capacity, memory capacity. That enables a lot of data transfers at high speed whenever the GPU or the CPU systems need it. On the networking side, we have new products with our DPU products, which are up to 400 gigabits per second bandwidth today, which again enable data transfers between nodes at really fast speed. Of course, our GPUs, the MI355X, which was released recently, we can do training, we can do inference. A lot of those workloads can run seamlessly on our GPUs as well. We have software support for that. We are also open standard. We have announced support for ultra accelerator links, and that enables us to meld with the industry and co-develop with the industry to take this AI story forward. Of course, partners are very key for us. We work very closely with MinIO, Enterprise DB, and Supermicro to bring the best solutions to the market so that the developers or the users can use it fully. Speaking of Enterprise DB, I just want to show a couple of things here. We have done benchmarking on AI workloads, and we see a lot of tremendous value in terms of our performance on the CPU side specifically. If you look at the charts there, I'll just call out two of the numbers here. The TPCX AI is a benchmark developed by the TPC org that specifically measures the entire workflow of AI and tells us what the benchmarks compare against. So in this particular case, we are showing about 70% better performance than our competition, the fifth generation Intel processors, and also up to 4x with our latest generation processors. And the second thing I want to call out here is the regular Llama 3.1, and that one has about 40% better performance with the 3-year-old processor that we have. And with the latest processor, we jump even higher with our performance compared to our competition. And that's kind of the benchmark that we work with and compare against the competition.
Yeah, I think this is why I think when it takes an ecosystem and there's not one solution for enterprise AI, especially when you start to look at data lakes and lakehouses and how they are servicing them. But you got to bring it together, and organizations are kind of looking for the easy button as well. Paul, you're the easy button. So
I'm glad to hear that, because the easy button is difficult, right?
Yes.
So everyone knows how difficult building hardware that actually works is, and Supermicro has been winning that competition for many years now. And really, the culmination of that is our data center building blocks, which we came from motherboards and then have just come to now where we are able to deliver all kinds of things for a data center, including liquid cooling, right? Because again, now the processors and everything is getting hotter with AI. It's now one of the things that everyone has to look at and have in their consideration in terms of architecting their solutions. The other thing that we are able to offer our customers is scale, right? Because again, the major challenge that people have with AI is how big does it need to be? What do I want to do? And we have lots of experts at Supermicro that can help in terms of scaling that workload to meet their requirements and what hardware is going to really meet that. So that's really exciting. From a portfolio perspective, we both have just unlimited number of SKUs. I mean, we have GPUs, we have CPUs. So in terms of database applications where you're really driving CPU, many choices. And again, this is where the consultative process that we have at Supermicro allows us to solve problems for our customers. Of course, I am all about storage. So with our storage and the storage category, we're really talking about scale again, because these are the highest capacity systems you can get. And that's both in flash and in 3.5 inch. So lots of options for our customers to deliver the performance, the TCO requirements of an AI stack. And just to dive into how I look at the world in terms of what storage needs from it. And again, this is my very simplified view. So really, I think of it in terms of there's data sources, and these data sources have been there forever, right? As soon as we turned on computers, we started creating data. Those data sources now can be utilized in a legacy type architecture with a data lake, right? So I can have this data, that historical data. And you may have applications that are, say, video surveillance or video analytics, where I might want to redirect that stream from where it went to in an enterprise storage stack to that AI stack, in which case then it can be processed and worked upon on the enterprise and get the usable information out of that in terms of the analytics load that you need to do there. So again, the portfolio stretches across the whole stack, and I'm really excited that I get to work with these people and build our ecosystem with these building blocks. So hardware and software partners are now all part of the Supermicro solution.
Yeah, I think it takes a village, right? It takes a village of hardware and software.
That's right.
Living in harmony, bringing a solution to the customer to fit their data lake or lakehouse needs, to put it mildly. Let's kind of dive into some questions here. Brenna, I'm going to go to you first. One of my favorite topics is open table formats. And how do you see that really changing what's going on and reshaping the role of the storage layer as it turns into more of a data platform layer?
That's a great question. So I think that the open table formats, along with performance enhancements for object storage, have really allowed object storage to become primary storage, allowed data lake houses to exist full stop. So previous iterations or legacy systems treated object storage as cheap, deep, and slow. And that doesn't look anything like the modern, enterprise, very agile data lakes that we have today. So I think the open table formats are responsible, along with enhancements in speed for object storage, for that revolution in thought and architecture. I also think that the open table formats are responsible for the introduction of other compute layers on top of object storage. Now I'm talking about vector databases and those LLM that we were talking about earlier, graph databases, visualization layers. They all can sit on top of object storage, and it's fast enough and secure enough and durable enough to become an entire stack on its own. So I really think it's along with performance enhancement object storage, the open table formats just lit the fire underneath this whole infrastructure and made all of this possible.
Yeah, I mean, when you start to talk about that, I think it also talks to the scale that everything is going to with these lake houses and data lakes, and where you're looking at this. One of the things, and I think you mentioned this up front in your slides, was the fact that, hey, I may have multiple different workloads running on there. Simon, from an EDB perspective, one of the things that I think about is maybe I have BI or an analytical workload running next to my operational workload. How do you look at Postgres and what EDB brings together with Postgres AI to really focus on controlling that and helping optimize that performance?
Right, yeah, and that's a very common situation. You have an operational database, and of course you want to then be able to do analytic queries on that, but you want to do those analytic queries on the fresh data in real time. Yeah. So with EDB Postgres AI, we actually have the capability to move the data from your operational databases into a columnar format in your lakehouse on mini-IO storage and on other storage options in real time. So now you no longer have that lag. If you're trying to figure out how many bottles did my factory produce today and how many defects there are, or you even want to run AI workloads on top of that to determine what the future may bring next, for the next day, then you can now do that with the data in real time. You no longer have this delay where you're running an ETL process at the end of the day. It's going there automatically into your lakehouse where it's in columnar format. And of course, columnar format is extremely effective for queries that have like very broad date ranges, right? So you're going to get the speed of OLTP, and you're also going to have that real time in your lakehouse, however you'd like it.
Yep. I look at it as columns forever. That's
Yeah,
where when I look
like
at these. Yeah, when I look at the lake houses, I mean, that's a lot of people are looking at that is how do I, actually I never throw anything out, but I keep creating more columns, and that gives me different views back in the data, which is, again, it brings on a whole nother issue, but I think you probably have solutions for that too. So, but look, Shiva, I think one of the things that I'm looking at with the fact that AMD, you have these processors that really drive a balance of performance and efficiency for organizations. How do you see that bringing value in the AI and the analytics realm for customers?
Oh, absolutely. So AMD's platform is, as a company, we have a full portfolio of AI products, and we get unique insights from the customers in this space as to what the customer needs, and we have built the platform based on that feedback, right? And what we have today is the industry-leading bandwidth in terms of NVMe store, like access to NVMe storage, PCI Express Gen 5, and we have super fast memory bandwidth. Also, the most number of memory channels, 12 memory channels per socket. So what that frees up a lot of data transfer bandwidth for all these AI operations. Apart from that, we also have 384 megabytes of cache per socket, which a lot of data storage companies make use of in terms of preloading the data for AI and those kind of things. Ultimately, the biggest goal here is to keep the data ready so that the GPU is not starving for the data. So these are the platform level innovations that AMD has done in this space that will tremendously, or it's already tremendously benefiting the customers and also the people who are benchmarking and getting things done faster because of these platforms. So yeah, I mean that is our main daily work here, to innovate continuously so that we keep the AI industry moving forward.
I think I look at that and go, okay, Paul, you showed a slide, a lot of different choices there. How do you help people from a hardware selection perspective as they're going through to right size for where they want the starting point to be? And also taking into it from a perspective, they want to hit today, but they also want to be planning for tomorrow as well.
The main thing is to listen to the customer. That is very important, right? Because the customer will have some very specific requirements, and they may have preferences. So I usually open with, listen to what their problem is and what they're currently using, whether it's working well or whether it has trouble, and what are those rubs. And try to find some other answers to that question. So, our partnerships with everybody in terms of software-defined storage has been really one of our great strengths. Supermicro has always been software-defined, and ever since I've joined Supermicro, that's been my charge, right, is to go after all the partners we can to make sure that we have solutions, whether those are compute solutions or whether those are storage. As an example, the two systems we have here today, these are very different architectures, right? But they do fit in the lakehouse and the data lake itself. So 3.5 inch is sort of the de facto standard for where I'm going to dump my data in large volume. And Flash, of course, this is featuring EDSFF media, which gives you, the ultimate efficiency, power, cooling, all the things that these large-scale data centers need. They need to shave off every watt of heat that's coming through the system. And with that kind of storage, I can do that, and I can deliver hundreds of millions of IOPS in a one-use system. So capacity, scaling, these are all things that we hear about from our customers. And then, of course, some customers are small, so we need to have solutions for them as well. And that's something that I'm always looking out for partners and how we can build this business together.
What is it really, that you would say is the number one piece of advice that you would give to organizations that are just getting started? Because we're in early innings with AI. I mean, we're in the year of inference, and everybody talks about agents, and RAG is still a big thing. And a lot of that is using data lakes and lake houses to bring and harness that data. what's one piece of advice that you would say, here's where you start so that you're protecting yourself out into the future? We'll start with you, Simon.
Yeah, so I think it's something Brenna mentioned too, is stick to open standards, right? Like iceberg format is one, right? And of course, a lot of the technology we've spoken about today, including EDBPostgres AI, lets you leverage that. But the idea is that there's a lot of different technologies that you're going to want to use, and the hottest thing today might not be the hottest thing tomorrow. But if you stick to open standards, you kind of make sure that your business is always going to be ready, right? And I think that that's sort of like a litmus test also for the right sort of company. I think you want to be working for a company that embraces open standards and is sort of willing to compete, because that the speed AI is moving today, just as long as you have your data in an open standard and you're taking an open approach to the market, then you'll be okay. But as soon as you get locked into a proprietary offering, then you may wake up one day and realize that you can't use the tools that you want.
Yeah. Brenna?
Well, I'm going to resonate with a lot of what you're saying, Simon.
Shocking. Go ahead anyway.
We all have that same answer.
So AI, it's always going to be innovating. There's always going to be a new platform, a new model, a new service that you're going to want to try, and you don't want to re-architect your whole storage backend or your whole architecture every time you want to adopt these new technologies. So, I would just exactly what Simon said. I would pick an object storage that's performant and durable and flexible, able to be deployed anywhere. And then I would choose an open table format like Apache Iceberg, and then I would choose whichever compute works for you and your workloads in that moment. And this will give you the flexibility to work with the AI technologies today, but also the ones for tomorrow.
Shiva, Paul, anything you want to add to that?
I'm going to plus one what Simon said again. But open source, right? AMD is all about open source. So thanks for that point out. But I'm going to talk in terms of a little bit of the infrastructure side of things. Obviously, any Gen AI deployment, there are major decisions to be made on the infrastructure side. And AI requires a wide spectrum of hardware. It's not GPUs only. GPUs definitely play a big part of it. And then there's CPUs. They have networking, storage. A lot of decisions have to be made in that space. So I would say, think about right-sizing your deployment and consider all these factors before investing in those deployments. Of course, Supermicro has got some really great solutions for all the things that you want in that space. So that's my key note for people who are going to try Gen AI or AI deployments.
Yeah, and the open standards in terms of managing the hardware. So from a Supermicro's perspective, we build our management interfaces on things like Redfish and other open standards that people can interact with and have experience with. They're part of Linux. It becomes easier for them in terms of navigating challenges that may come up with hardware. So yeah, open standards is absolutely the first starting point, and then of course patience, because all these new technologies will have a bad effect if you do the wrong thing. And so be patient, really understand what you're trying to achieve, and then communicate to your partners what you're trying to achieve so there isn't a disconnect after they've deployed.
Yeah, I think you just hit the nail on the head with it's understanding a lot of times the business use case and outcome that you're trying to do, because I think people run into and go, well, first I needed a chatbot and I needed an LLM. Yeah. Now I need inference and a larger and RAG, and then okay, now we're going into agents and I need multi pieces into this agent. I think it's, well, what problem are you solving? And plan for that. And I also say take it in bite-sized chunks as well. Yeah. Start with somewhere, gain success, gain feedback on that so you understand. I think one thing that's also I've been hearing throughout the summit has been storage latency performance is definitely a key critical, I guess you could say, it can potentially torpedo your AI, your enterprise AI. What are you seeing from the technical requirements and how you're easing that latency? We'll start with Brenna this time.
My favorite question. So MinIO store is faster than S3 even deployed to AWS. We're the fastest object store on the least amount of hardware, which means we can get you to your first byte faster and more economically than any other on-prem object store on the market. We just released support for S3 Express API, which when we benchmarked against Amazon's S3 Express Zone 1, we found to have much higher throughput, especially for large objects, which are really prevalent in AI. So it's not going to be us that's going to slow you down. We're going to go as fast as you need to go.
Yeah, I think people would also find that large objects are really not that large when you think about the file sizes and object sizes that are being used in AI. What are you seeing from that from a latency perspective, and how you're balancing that from an EDB perspective?
Yeah, well, EDBPostgres AI specifically helps in a few areas there. One is tiered tables, and what that means, or tiered storage in general, that means that if you have a very big database table, we'll automatically move the older data onto object storage, right, from your operational database. And this means the operational database will be faster. It means that you can, also means that you can just kind of set and forget, right? And by moving things into the right sort of storage, right, then you're going to get much faster, responses in a very quick operational database, because that way only the data that you need to have there is there, and then everything is in columnar storage for analytic queries. And then I think another one is when we think about how we partnered on the Sovereign Data and AI Factory with Supermicro, we really did decide to make sure that customers have choice with the sort of object storage that they have. We don't lock people down. Minio is a great option, by the way, and you can sort of grow at your own pace. So I think that approach was what customers wanted, and it means that what's fastest today, the latest appliance, whether it's Minio or another storage vendor, 6 months from now, there's going to be something even faster. So you have to keep that in mind, right? Where we are today, already the video cards that we looked at last year, which were blowing us away, now NVIDIA has video cards that are way faster. So keep in mind that you want that flexibility when you think of your design, that soon you're going to want even more of it, and that next generation, you're going to want to be able to plug that right into your infrastructure to leverage it.
Yeah, and I think, again, and Shiva, going back to some of the stuff everybody's been saying here, it's one of those things, it's a balance between things like GPUs and CPUs, and there's a whole thing, because you also have the whole KV cache and how that is feeding in and stuff of that. What are you seeing from a latency reduction perspective from the AMD view of the world?
So AMD is all about unblocking innovation, right? And we take a lot of care in terms of unblocking. The moment we see anything like a performance drop or anything, we make sure that we get that resolved as soon as possible. For example, like we pick up the phone and talk to EDB or MinIO to say, hey, what's going on here, right? Or Supermicro for that matter. Like, well, let's figure this problem out. And most of the time at the spec level, we make sure that we are, latency, very less latency for our operations. But then, at the software level, also we have to make sure that the customer is not seeing those kind of bottlenecks that blocks their innovative spirit. So we do it at the hardware level. I showed some benchmarks as well in one of the slides. Is that is a fruit or the result of all these work that we have done with the ecosystem, with the open ecosystem, to make sure that the users are not penalized for using an AMD platform, right? So that's the biggest goal here.
Yeah, Paul, it would seem like this is a major focus for you as you're
Absolutely.
building out these systems.
Yeah, and then one of the things that Shiva didn't mention was, of course, this whole RDMA direct to the GPUs that AMD is working on as well, and it's kind of a new industry standard in terms of AI workloads. Supermicro, of course, we're always looking at the performance of our systems. So I always tell my customers and my partners and everything, hey, we deliver you the bandwidth, now you have to deliver the throughput. So basically, with your application, the doors are wide open. Let's see what we can do together. Like for instance, this petascale system, just in an FIO straight to the processor, I'm getting 230 gigabytes per second bandwidth, getting millions of IOPS, and that's just the start, right? In PCI Gen 5, Gen 6 is around the corner. The other thing that people have to keep in mind is with GPUs, as Shiva and Brenna talked about, the product cycle of those is coming along super quick, right? So where a processor might be an 18-month process, we're seeing 16, 12, where generations of the GPUs change. So huge changes there in terms of time to market and time to value for a partner like that you'd have. And Supermicro is always there with the latest and greatest hardware.
Yeah, I think that to me is the rate of change here is, we used to talk in 5 years, 10 years, what's your planning horizons for IT organizations and platform engineering, but now we're at a point where 18 months is a long time in this industry right now, and things are moving, especially with enterprise AI, it's moving so quickly. So final question here for the group is that as you talk to the people on the other side of the screen here, and as they consider enterprise AI, because there's so much out there and so many things to figure out, what's one piece of advice you give to them that they should take away about, hey, as they start on this journey, because we're still in early innings, what's something they should consider from this perspective of we've been talking about today to get started? I'll go with you, Simon.
Sure, yeah. I'm going to choose something a little bit unique because I think this is practical. Think about the finance angle. And by the way, Supermicro, when we work with customers, often, listen, this is going to be expensive, right? So often we've worked together with Supermicro to provide, leasing for the customer, whatever they need. And the reason is this is no longer the era of, low-cost commodity hardware. Once you get into the AI workloads, even, other sorts of workloads maybe, but AI, you're going to need really powerful video cards from AMD or who knows what, and all that equipment is going to start raising questions internally in the org in terms of how we approach it. Even if you don't do it yourself, your cost may be even more expensive. If you look at the cloud providers, you're looking at over $60 an hour, which is, if you do that math, it's over $45,000 per month, or over $500,000 a year, just to rent on demand, right, an 8 GPU system. So you start looking at all these bills and you think, how am I going to be creative about making a plan for my organization that makes it affordable? How do I make it modular so that way I don't invest for 2 years from now, but then everything is twice as fast in 1 year from now? So I would recommend engaging with Supermicro or any of the vendors here really, and they can help build a plan and choose the right combination of equipment for today and financing options that will work for the business. And that way, when you do make that pitch, hey, we're going to double our business efficiency by using AI, then you'll have a full suite of options to tackle the expenses that you're going to hit.
And your TCO and what the ROI will be as well, which is very important. Brenna?
Well, I just want to echo what Simon's saying about picking like a stack that's modular. I mean, you can swap and drop as you need, and I think this is very much the case with compute. With storage, you want to make good choices from the start because your storage layer is what makes or breaks your data lakehouse. It can only go as fast or be as safe or be as durable or as flexible as your underlying storage. So object storage is primary storage for a data lakehouse stack and for all of your modern data needs, and make good decisions, choose modular, disaggregate your storage and compute.
I always try to make good decisions,
Yeah.
but not always, especially late at night. But Shiva, what's your perspective on this, and what's one piece of advice that you think people should consider?
Yeah, we talk to a lot of customers, and I'll tell you what one common theme is across a lot of these customers is ROI, right? And what we find out is the companies that are very patient with their ROI get the most out of their AI deployments. And the ones that are like hurriedly, I need results and money back in 1 year, are the ones who give up too soon. AI is kind of a long journey, and that's the key message that they should remember is that you're not going to get ROI in the first year, right? I mean, point blank. But as the best way is to start with something small, something like a pilot project, and get it done, and then go and build on top of that based on the expertise you can get. And also you might be able to hire better people as you move along. And those are the baby steps that needs to be taken for us to reach the level of an ROI discussion, right? So that's the one piece of advice I'd give them.
Yeah, I agree with you. I always call it crawl, walk, run.
Yeah.
And it's how do you get success begins success, and even failure sometimes is success because you learn from that failure and then move on to understand and then build what you need to from an AI perspective, I think in particular. But you need the flexibility underneath it, which, Paul, what's your last piece of advice here?
So really, enterprise is our growing edge at Supermicro. So we've been supporting OEMs and large-scale cloud organizations and DevOps organizations, and now really enterprise is that last mile where you think, hey, that should be easy, but again, from a scaling perspective, we've always been much larger scale, attacking these very large-scale problems. Enterprise AI is still large scale for the customer. For us, that would be small scale, and we're able to use our expertise that we have with these large-scale customers to deliver enterprise solutions, services, support, all the things that an enterprise needs to actually do the work that they're doing. And so that's my takeaway is, if you haven't looked at Supermicro in a while in terms of an enterprise application, absolutely take a look at where we offer today with all of our software partners, all of the flexibility and all the open standards that we're using to help everybody build these AI solutions.
I think that's a great place to leave it. So I want to thank you all for coming on board today. This has been really great. I think people are going to take away a lot of really good insight. So thank you very much.
Thank you.
Happy to be here.
Yep, happy to be.
And thank you for watching this episode of the Supermicro Open Storage Summit. Hang tight. We'll be back with more.